I have to start the recording. I'm sorry. All right, so is everyone seeing the section 8.2 set of notes?
Right now I just see the trigonometry formula sheet.
Okay. Okay, I'm gonna get it together here in just a second. Okay, is everyone seeing the set of notes now?
Yes, I am.
Okay. Trying to learn how to navigate between screens. Okay, so here we're going to take a look at the 6 trig functions. And the 6 trig functions are based on a coordinates x and y ordered pair. And as we can see from the diagram, notice we have an x and a y axis. We do have an angle that is in standard position, so notice that it starts from the positive x-axis. That's the initial side. And the terminal side is rotated counterclockwise. And notice we have a set of coordinates, x, comma, y. Okay, this angle is said to be in the second quadrant. Once you drop what's called a perpendicular, so notice from this point, this ordered pair point, we always drop the perpendicular to the x-axis. So just keep in mind from geometric terms, perpendicular means 90 degrees. So once you drop what's called a perpendicular, notice it forms a 90 degree. And we can also form an imaginary right triangle. Now, up until this point, the Pythagorean theorem has probably taken the form c squared equal to a squared plus b squared. The symbols change slightly. Instead of using a, we'll use x. Instead of using b, we'll use y. So those would be your legs. And c, which is the hypotenuse, we're going to call that r. So here's one thing about r. In order to find r, you would simply take the square root of x squared plus y squared. Okay, so this is basic Pythagorean theorem, just using different variables. All right, so here's trig functions as they relate to our x and y ordered pair. The sine of angle, right? So whenever you see this symbol, this is the Greek letter theta, and theta represents an unknown angle. So this says that the sine of theta, which is an unknown angle, is equal to y over r. The cosine of theta is x over r. The tangent of theta is y over x. And then we have what are called the reciprocals. The reciprocal of sine is cosecant, and cosecant is r over y. The reciprocal for cosine is secant, that's r over x. and the reciprocal of tangent is cotangent. And the cotangent of theta is x over y. If you take a look at your trig formula sheet, you don't actually see those 6 trig functions written on this formula sheet. You may want to write them on your formula sheet. I don't actually require that you memorize formulas in the course, but knowing those 6 basic trig functions can help out a lot. So you can write those 6 trig functions on this formula sheet. I just want to warn you that these formulas are not on the formula sheet. So again, sine is y over r, cosine is x over r, tangent is y over x, and then we have our reciprocals. All right, we're going to find the function values of an angle. So we're given this example. It says the terminal side of angle beta, which is in standard position, it goes through the points -3, -4, and we're asked to find the values of the six trig functions of beta. So I'm going to go back to my camera. Okay. Can everyone see my writing?
Yes.
Okay. All right, so I'm actually going to sketch that out. So I'm going to draw with an X and a Y axis. And it says that it's in standard position. So it's going to start along the positive x-axis. And we're given that it goes through the points -3, -4. All right, so I'm going to sketch that out on my graph. So my ordered pair point is -3, -4. So I'm going to plot that out. So I'm at my origin. My x coordinate is -3, so I'm going to move 3 places to the left. My y coordinate is -4. So I'm going to go down 4 spots. And this is my point. So this is serves as our terminal side, and we have our angle. Now, it doesn't really say in the directions, but I believe we're going to treat this as a positive angle. So that terminal side is rotated counterclockwise. Okay, so that's what the arrow indicates. So next we must do what's called drop a perpendicular. You always want to make sure that you drop your perpendicular always to the x-axis. So here's the point located in my third quadrant. I'm going to drop a perpendicular, which is this imaginary line, and that forms a right angle. So this gives us a right triangle. This would serve as side x, because that's along the x-axis. This side would serve as side y. And we have our hypotenuse. Recall that the hypotenuse is opposite the right angle. So this is side r. One thing about the formula sheets, I'm not going to flip screen right But if you go back, it says that R has to be positive. R is always a positive value. Right? And this is angle beta. So what we're asked to do is we're asked to find the sine of beta, the cosine of beta, the tangent of beta. We're going to find the reciprocal of sine, which is cosecant. We're going to find the reciprocal of cosine, which is secant. And we're going to find the cotangent, which is the reciprocal of tangent. So we know that x is equal to -3. Y is equal to -4. We don't know R or Y. So we're going to find R. From the previous formulas, R was equal to the square root of x squared plus y squared. All right, remember, that's just the Pythagorean theorem. So I'm going to substitute in -3 for x and -4 for y. All right, so once you square a negative, it returns a positive. And we have R, which is always a positive number. R is equal to 5. All right, so any questions about the sketch angle up to this point?
No.
Okay. So now here's where the 6 trig functions come into play. The sine of some angle, in this case that angle is beta, that was equal to y over r. The cosine of beta is equal to x over r. The tangent of beta is y over x. For the cosecant of beta, since cosecant and sine are reciprocals, the cosecant of beta is r over y. Secant is the reciprocal of cosine, so the secant is r over x. And the cotangent is x over y. So since we know x, y, and r, we can now find the 6 trig functions. So the sine of angle beta is y over r. The y coordinate is -4. The value for r is 5. So we get a sine of 4/5. The cosine is x over r. So we have -3/5. The tangent is y over x. So a negative divided by a negative gives us a positive. And then we have our reciprocal. So the reciprocal of cosecant is sine. So I can simply reciprocate. The reciprocal of secant is cosine. And so I can reciprocate the cosine. And reciprocate just means to interchange the numerator and the denominator. The sine, however, will remain the same. And the reciprocal for cotangent is tangent. or I could use my relationships. X is -3, Y is -4, and I have a tangent of 3/4. Are any questions about that example?
No.
Okay. Okay, so next we're talking about reciprocal identities. And these reciprocal identities are the same as the identities we just talked about. The only difference is instead of using X, Y, and R, they're actually using the trig functions themselves. For example, the sine of theta is 1 over the cosecant of theta. The cosine of theta is 1 divided by secant theta, and the tangent is 1 divided by the cotangent. What really makes these functions stand out are the second set of formulas for cosecant, for secant, and for cotangent theta. So here we have cosecant of theta is 1 divided by sine of theta. If we take a look at the calculator, okay, can everyone see my calculator?
No.
Okay. Excellent. Save it. Okay, give me 1 second. I'm going to try to bring that up. Okay, I got to bring that up separately. So has anyone seen my calculator the entire time?
I haven't.
Okay, give me 1 second. I'm gonna get my hand here. Let's see. All right, is everybody seeing my calculator now?
I am.
Okay. All right, so on this calculator and the reciprocal functions. Now we talked about sine, cosine, and tangent. So on this calculator, I clearly see a sine, cosine, and a tangent. However, this sine to the negative first power, that's not cosecant. This is cosine, and this is cosine to the negative first power. That cosine to the negative first power is not the reciprocal for cosine. Okay, that's not a secant function. And then lastly, this tangent to the negative first on the calculator, that is not a cotangent button. All right, so I just want to show some things with this calculator and those formulas. So here's just an example using the reciprocal formulas we just talked about. Now we don't really use the reciprocal formula for sine, cosine, and tangent. However, if you wanted to find, let's say, the cosecant of 30 degrees, and let's say you were asked to find that using your calculator, how would you do it? If this is not a, if you don't have a cosecant function. Well, what you would do is you would use reciprocal functions. So the reciprocal function for cosecant, it says that the cosecant of theta of some angle is equal to 1 divided by the sine of some angle. So if you were asked to find the cosecant of 30, you would actually put this in your calculator as 1 divided by the sine of 30 degrees. Because this is not a cosecant function. Okay. So I'm going to put it in the calculator. But here's where I got to warn you with using your calculator. In this course, can everybody see the display on my calculator?
Yes.
The number. Okay. So I'm going to clear that out. And I want to go into mode. Once you're in the mode, my second line, I have radian and degree modes. In this class, it's going to be very important to make sure that you're in the right mode. So I'm going to show you an example of where this can kind of go wrong if you're not in the right mode. Notice that now I have radian mode. So in order to set your modes, you would go to degree. If you wanted degree, you would press enter. And now we'll put your calculator in degree mode. If you want radian, you would highlight radian and press enter. All right. So I'm in radian mode. I just want to show you a couple things. I'm going to go back to my home screen. And when you hear me say home screen, that's this quit key. So if I hit second in mode, which is quit, that takes me to my home screen. And I'm going to put in the cosine of 30 degrees. Right? But keep in mind, I'm in radian mode. So my calculator gives me the cosine of 30 degrees is 0.154. If I change the mode on my calculator, so I'm going to go back in, I want to change the mode to degree. I'm going to go back to my home screen. And if I put in the cosine of 30 degrees again, notice I get a completely different answer. Right? Whenever you're working with your trig functions, you have to make sure you're in the right mode. So here's basically how you determine the right mode. If you're working with degree measures, your calculator should be in degree mode. If you're working with radian measures, your calculator should be in radian mode. So in order to correctly solve this example, I should be in degree mode, right? Because my angle measure is given in degree. So I'm going to clear out my home screen. I'm going to go back into mode. I want to make sure I'm in degree mode. I'm going to lock that in with enter. And now if I go back to my home screen, and if I were asked to find the cosecant of 30, I would enter that in my calculator as 1 divided by the sine of 30. So notice I didn't actually put in a degree symbol this time because I'm in degree mode. And if I hit enter, we get 2. Right, so the cosecant of 30 degrees is equal to 2. All right, so any questions about this example? You got to be careful what mode you're in. And if you're dealing with the reciprocal function, you just want to make sure you put in the reciprocal. And we're going to talk about these things later. These are actually called arc functions or inverse functions. All right, so I'm going to go back to the lecture notes. Okay, if it'll let me. Okay, is everyone seeing the lecture notes now?
Yes.
Okay. All right, so we looked at the cosecant. You have to enter that in as 1 over the sine. The secant is 1 divided by the cosine, and the cotangent is 1 divided by tangent. All right, so the most important thing to take away from this slide is the second row of functions is how you would evaluate reciprocals in your calculator. Okay, when I say reciprocals, I'm talking about cosecant, secant, and cotangent. All right, in this example, we're asked to use a reciprocal identity. We're taking a look at an example on a calculator, but this is an example that requires an exact answer. So we're asked to find sine if we're given that cosecant is negative square root over 12. All right, so I'm going to switch over to the camera. So in this example, we're asked to find sine of theta if cosecant of theta is equal to negative 12 over the square root of 2. Well, based on our formulas, we know that the sine of theta is equal to 1 divided by cosecant of theta. So I can rewrite the sine of theta as 1 divided by the cosecant of theta, and the cosecant of theta is negative square root of 12 over 2. 1 divided by any fraction would simply give me the reciprocal of the fraction in the denominator. So 1 divided by square root of negative square root of 12 over 2 simplifies to give us negative 2 divided by the square root of 12. Right, but there's a couple of things wrong with this answer. First off, we must rationalize the denominator. Right, just as in the algebra course, you had to rationalize all denominators, and to rationalize a denominator, that simply means we want to take the square roots out of the denominator. The second problem is the denominator is not simplified. All radicals have to be simplified, and all radicals must be, all denominators have to be rationalized. So the first thing I'm going to do is simplify the denominator. So we have a negative and 2 in the numerator. I'm going to simplify the square root of 12. I'm going to write that as the square root of 4 times the square root of 3. Right, because 4 times 3 is 12. I can rewrite the square root of 4 is 2. So this gives me negative 2 divided by 2 times the square root of 3. My 2's are going to cancel. So I have -1 divided by the square root of 3. However, I still have a radical in the denominator, so I want to rationalize the denominator. Right. So in order to rationalize the denominator, I'm going to multiply the top and the bottom by the denominator. Right, so what I'm actually doing is I'm multiplying by a special form of 1, because anything over itself is 1. Whenever you multiply 1, you don't change the value of you don't change the value, you can change the way your problem is expressed. Right, so when I rationalize my denominator, I have the square root of 3 over the square root of 9, but it's still negative. Because 1 times the square root of 3 is square root of 3. The square root of 3 times the square root of 3 is 9. For a final result of square root of negative square root of 3 over 3. So just one thing in this class, well, I guess a couple of things. You will have to simplify radicals. So here I had to simplify the square root of 12 as 2 times the square root of 3. And you will have to rationalize denominators. So we have a final result of negative square root of 3 over 3. And any questions about that?
Any way to do this?
Unfortunately not, because there's a square root in the problem.
Okay.
And the calculator won't give you a square root, it'll give you that decimal approximation. Now some you'll be able to do in the calculator. Right, like the first example we did by hand, we got like a 2. And then other problems, not so much.
Okay, so when there's a square root in the problem, we have to, like, as you say, break it all the way down to those terms and cents.
That's right. Those problems are the ones where you're asked to write out the exact answer. And the reason why you can't write it out exactly is because the square root of 3 is an irrational number and it never stops, it never repeats, you can never finish writing it, but you can symbolize that with the square root of 3.
Okay.
Okay. Okay, I'm going to go back to the all right, so on the next slide, we're looking at sign and range of function values. And even though this looks a little bit complicated, there's a simpler way to remember what's going on in this chart. But just taking a look at the chart itself, what it gives you are the value for the sign of each trig function in each quadrant. Right, so this is how you decipher through this chart. The sign of some angle is positive in the first quadrant, is also positive in the second quadrant, but it's negative in the third and fourth quadrants. The cosine is positive in the first quadrant, negative in the second and third quadrants, and positive in the fourth quadrant. So now you will see questions such as this. I believe there's one that's on the exam. It says identify the quadrant or quadrants of any angle theta that satisfies these conditions. Now, as we go along further in the course, anytime you see this greater than 0, that simply means positive. Anytime you see less than 0, that simply means negative, right? Because if you think about it, any number that's greater than 0 is positive, and any number that's less than 0 is negative. This is sort of saying the same thing, just in symbols. Now, the easier way I was talking about of remembering this thing, I'm going to go back to the document camera for just a second. And this little chart I'm going to draw, I'm going to build upon this. So, and what it is basically a unit circle, right? This is my X and Y axis. I'm going to put my degree measures, 0 degrees. Now, I'm only going to list out the positive. 90 degrees, 180, 270, and 360. And you should also know these are the quadrantal angles. You should also know their radian equivalents. So 90 degrees, that's equal to pi over 2 radians. 180 degrees is equal to pi. 270 degrees is equal to 3 pi over 2. And then 360 degrees is 2 pi. So I did forget one. 0 degrees, that's equal to 0 radians. And then that sort of repeats. Now, a simpler way to remember the signs of the 6 trig functions in these quadrants, I'm going to go ahead and title this thing as reference angles. Now, we hadn't talked about reference angles quite yet, but we're going to build up to that, and we're going to build on this chart. All right, so first off, this is just the unit circle, right, with just quadrantal angles. And then there's a slogan I'm going to use, and the slogan is all students take courses. All right, so this all students take courses. So what this alludes to, all students take courses. So I'm just taking the first letter from each word, and notice I'm starting at quadrant 1, going around quadrant 2, quadrant 3, quadrant 4. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So this is what this little slogan means. In the first quadrant, the A for all means that all 6 trig functions are positive. So the sign is positive. So I'm going to write that out as greater than 0. Cosine is positive. Tangent is positive. And then the reciprocal. This reciprocal for sine is cosecant. The reciprocal for cosine is secant. The reciprocal for tangent is cotangent. So in the first quadrant, all 6 trig functions are positive. The students allude to, in the second quadrant, only the sign and its reciprocal, the cosecant, are positive. Everything else is negative. And we'll kind of line this up with that chart. In the third quadrant, the T in take alludes to the fact that the tangent and its reciprocal, the cotangent, are positive. And in the fourth quadrant, the C for courses alludes to the fact that the cosine and its reciprocal, the secant, are positive. Everything else is negative. All right, so any questions about this chart? Okay, so like I said, we're going to build upon this when we actually talk about reference angles. And if you're asked to find the value of a trig function, right, we're going to build upon this. All right, so initially we're kind of using it to tell which quadrants, the signs for the 6 trig functions in each quadrant. All right, so I'm going to go back to the notes. All right, so if you kind of line up this chart based on what we just went through, right? If you take the tangent, for example, notice in our slogan, all students take courses. The tangent is positive only in the first and the third quadrant, right? Because everything's positive in the first quadrant, and the all students take, right? The tangent is positive in the third quadrant, it's negative in the other quadrants. Cotangent, right? It's the reciprocal for tangent, so it takes on the same sign as well as secant and cosecant. And they take on the same signs as their reciprocals. All right, so now how do you answer this question, though? It says we're trying to find the quadrant or quadrants of any angle that satisfies the sign as being positive and the tangent as being negative. So the sign is positive and the tangent is negative. So I'm going to go back to the document camera. So first I'm just going to start positive. I mean, just that's the first thing I'm given. And I'm going to narrow it down to a couple of quadrants. Now, if my sign can only be positive, then that angle can only lie in the first quadrant, because the sign is positive in the first quadrant, or the second quadrant, right? So I can automatically eliminate the third and the fourth quadrants for my angle. Now, if I take a look at the second stipulation, it says that the tangent has to be negative. So if I look at my first 2 quadrants, in which quadrant is the tangent negative? Well, that would have to be quadrant 2, right? Because the tangent is positive in quadrant 1. So in order to answer that question, the angle must lie in quadrant 2. Because in quadrant 2, the sine is positive, and in quadrant 2, the tangent is negative. All right, so the solution there would be quadrant 2. All right, any questions about that? Okay, now the next couple of slides go through a couple of facts. I'm going to just kind of breeze through these things. And I actually want to get to this particular side. And it just this slide summarizes these previous 2 slides. So this slide says that the sine, and remember from our 6 trig functions, the sine was y over r. The sine has to be in between -1 and +1. That means that the sine value can never be smaller than -1. It can never be greater than +1. Same as the cosine. The cosine is x over r. So the cosine is greater than or equal to -1 and less than or equal to +1. So it takes on the same characteristics. It can never be less than -1. It can never be greater than +1. It says that the tangent and the cotangent can be equal to any number. The secant, however, has to be less than or equal to -1, or it can be greater than or equal to +1. And the same is true for the cosine. Now, if you plan to take physics, I think this is one of the things you need to know going into physics. I'm going to go in a little bit more detail about sine and cosine and why this is true. It can never be less than -1 or greater than +1. So, is everybody seeing my?
Yes.
Okay. I'm asking these questions because I'm getting funny looking screens. But just kind of reviewing a right triangle. In a right triangle, you basically have legs and a hypotenuse. Right? In order for it to be a right triangle, you must have a right angle. Now, one special fact about hypotenuse, it's always the longest side. In any right triangle, it's always opposite the right angle, and it's always the longest side. Okay. So I'm going to kind of set this up as X, Y, and R because that's what we're dealing with. And if you just look at this numerically, if we talk about the sine, right, the sine of some angle is Y over R. This is the reason why the sine can never be less than -1 or greater than +1. If R is always the longest side, I'm going to just say that R is 5. So I'm just kind of sticking in numbers for Y. So I'm sticking in 1, 2, 3, and 4 for Y. And let's just say that R is 5 if you look at these numbers, if R is always bigger than Y, this number, the sign, can never exceed 1. Because if the leg and the hypotenuse can never be the same side, and if R, or the hypotenuse, has to be the longest side, mathematically the sign can never be larger than 1. Right? Just based on this fact. Same thing is true for the cosine. The cosine is x over R. So this leg can never be bigger or the same size as R, because R has to be the longest side. The same thing is true here. The cosine can never be greater than 1. And conversely, it can never be less than -1. All right, so in a roundabout way, that's what's going on with these intervals. Okay, the tangent, which is y over x, y can be bigger than x, x can be bigger than y. There's no stipulations about y and x. So therefore, the tangents and cotangents can take on any number. Since the secant is the reciprocal for cosine, then it can only take on values outside of the cosine. So since the cosine can't be smaller than -1, the secant can, and it must be. Since the cosine cannot exceed +1, the secant can, because if you flip over your fraction, right, it's going to be something greater than 1. So the secant and the cosecant are less than -1 and greater than +1. So just knowing those things, that's just kind of based off the fact that in the right triangle, the hypotenuse is the longest side. So we're asked to decide whether these things are possible. This first example wants us to determine if the sine can ever equal to the square root of 8. Well, if you put the square root of 8 in your calculator, you should get 2.828, which is a value that's greater than 1. So for example A, that's not possible. Okay, it's impossible to have a sine value greater than 1. And square root of 8 is greater than 1. For the second example, the tangent of theta is 110.47. That is actually true because the tangent can take on any number. And then lastly, the secant is equal to 0.6. Well, if we look at our range values, notice that the secant has to be less than -1 and greater than +1. Since 0.6 is less than -1 but greater than, it's less than +1 and it's greater than -1, that would fall outside of the limits for secant. So example C is not possible. Okay, a secant value would have to be greater than 1 and be less than -1. Okay, so the only possible statement is B. All right, now we're going to take a look at the Pythagorean identities. And I'm going to pull up The formula sheet. Yeah. So everyone is seeing my formula sheet, correct?
Yes.
Okay, now if you notice this second block, or this second row, I should say, it mentions the Pythagorean identities. So notice up to this point, the Pythagorean identity has just basically been c squared is equal to a squared plus b squared. But you'll notice these other forms, sine squared theta plus cosine squared theta equals to 1. You'll notice this Pythagorean theorem as well as this Pythagorean theorem. So I'll take this first one and show you where this kind of comes into play. I'm going to go back to the document camera for just a second. Okay, that's how you do it. All right, so we have r squared is equal to x squared plus y squared. Right. So up until this point, we've been using c squared equal to a squared plus b squared, but we're changing the variables. If I were to take this equation, and let's say I divide both sides by x squared. Excuse me, we're going to divide both sides by r squared. Divide both sides by r squared. Right? Because remember from algebra, whatever you do to one side, you have to do the exact same thing to both sides. So if I divide one side by apples, I have to divide the other side by apples. So here I'm dividing both sides by r squared. So I'm going to divide the left-hand side by r squared and the right-hand side by r squared. I want you to see where this is coming from. For my right-hand side, I'm going to rewrite this as x squared over r squared plus y squared over r squared. So the only thing I did was just use something called the divide by monomial formula. And it says that if you have a monomial or one term in the denominator, then you have to treat the denominator as being a denominator for every term in the numerator. Right, so I simply rewritten this. And now I'm going to play one slight trick on this. So now anything over itself is 1. So r squared over r squared is 1. On the right hand side, I'm going to factor out this square. So here's what I mean by that. I'm going to rewrite x squared over r squared as x over r squared. So if you reverse the process, you will get x squared over r squared. And I'm going to do the same thing for that last term. So now remember from previous formulas, the sine of some angle was y over r, and the cosine of some angle was x over r. So I'm actually going to use those relationships here. Here I have y over r, and here I have x over r. So I can rewrite this Pythagorean theorem as 1 is equal to cosine squared theta plus sine squared theta. And that's the first result for the Pythagorean theorem. So now, as we saw on the slides, there were actually 3. This was 1, right? And then there were 2 more. This is how the other 2 Pythagorean identities are produced. You would take this equation, and we divided both sides by r squared. We saw what happens. You would divide both sides by x squared, cancel and reduce. You would divide, to find the last identity, you would divide both sides by y squared. So that is where these other Pythagorean identities come to play. Okay. So if you actually want to find it out for yourself, just take that equation and divide both sides by y squared, and one of these should pop out. And in order to find the other identity, divide both sides by x squared. Okay, now I bring those up because we will use these Pythagorean identities. We'll actually use all 3 of them somewhere down the line. And those identities are used in this example. Okay, so there is like a problem buried up. There is a problem on this slide. So notice that we have Pythagorean identities, those 3 identities. And then we're given an example. We're asked to find the sine of theta and the cosine of theta if we're given that the tangent of theta is 4/3 and our angle is in the 3rd quadrant. So now, as far as the slides are concerned, they actually use Pythagorean identities to find the sine and the cosine. All right, so we're going to take a look at the slide example, but I'm actually going to sketch it out. I'm going to do a triangle sketch solution. So in math, as you well know by now, there's more than one way to work a problem out. So on the slides, they're using the formulas, which is a bit confusing to work out. And then there's a triangle sketch. So as we take a look at the solution on the slide, right, we're given that the tangent is 4/3, and we're asked to find the sine and the cosine. So the second Pythagorean identity was chosen. 4/3 was substituted in the tangent. 1 plus 4/3 squared was added together. So notice it gives you negative 5/3. Once you simplify, and then you take the reciprocal for secant, which is cosine, and you get 3/5. And then in order to find the sine, they took the negative 3/5 value, which they found, used the first Pythagorean identity, substituted the cosine for negative 3/5. They worked it out. Now here's one thing about working this out. Sine squared theta is equal to 16/25, so they took the square root of both sides to get 16/5, because the square root, the square root of 16 is 4. The square root of 25 is 5. But notice that the answer is negative 4/5. And mathematically, when you take the square root of both sides, this would produce a positive. So if you're working this out using formulas, you have to be careful, because if you're in the third quadrant, if you refer back to that all students take courses, in the third quadrant, the only positive angles are tangent and cotangent. All right, but I want to show you a bit better solution than this solution. So I'm going to go back to the document camera. And we're going to construct a triangle sketch. And let me find a sheet of paper. All right, so we were given that find sine theta and cosine theta if the tangent of theta is 4/3 and theta is in the third quadrant. All right. So I'm going to sketch out the angle. Okay. So just a couple things we have to keep in mind. The tangent of some angle is y over x. So our y value should be 4, and our x value should be 3. But the angle is in quadrant 3, so my angle is in the third quadrant. So if I use my coordinates, x should be 3, but instead of a positive 3, it should be a negative 3. And then y should be a negative 4. Right. 1, 2, 3, 4. And this is where you can put some things in a triangle sketch as far as your sign is concerned versus mathematically where you may or may not get the right sign. All right, so this is angles in standard position. So this is 3, and then this is negative 4. This is our angle. I'm going to assume that it's being rotated. It's a positive angle. Okay. So now any questions? So notice that I have that my tangent is positive. It says 4/3, but when I sketch it out, I see that my x alone is negative and my y alone is negative. And when you put a y over an x, a negative divided by a negative, that's what forces a positive. But when I do a triangle sketch, notice that my x coordinate and my y coordinate are actually negative. So we have x is -3. We have y is -4. We're going to find r. So with our formulas from previous, we know that r is equal to the square root of x squared plus y squared. So I'm going to substitute x for -3 and y for -4. So I believe when all the dust is on that, you should get 5. Right, because -3 squared is 9, -4 squared is 16, 9 plus 16 is 25, square root of 25 is 5. Notice that r must always be a positive number. So any questions about this triangle sketch? Right, our angle is in the third quadrant. We were given the tangent, and the coordinates for tangent are y over x. So y was 4, x was 3. When we sketched that out, however, we saw that the 3 and the 4 individually were negative. So now I know x, y, and r, so we can now find the sine of theta. Make sure I just call that angle theta. And we can also find the cosine of theta. So from our list of formulas, the sine is y over r. If I look at my triangle sketch, y is -4, r is 5. My cosine is equal to x over r. So if I look at my triangle sketch, x is -3, r is 5, so we get -3/5. So if you compare that to the Pythagorean identity solution, notice we didn't have to change any signs in the end. Okay, we were able to pull out the correct signs from the triangle. All right, any questions about that example? So now that's true for some of the problems. I believe in the homework. A lot of these things are worked out using the Pythagorean identity types solutions. But rest assured that if it gives you a quadrant, and if you're given a trig function, you can perform what's called a triangle sketch. And once you have the values for x, for y, and for r, you could find all 6 trig functions. So based on this triangle sketch, I could find the tangent, and I can also find the 3 reciprocals. All right, any questions about anything that we went through today?
No.
All right, so hopefully this wasn't too painful of an experience. I'm still trying to learn Blackboard and flipping through the screens, and I wasn't quite sure that I thought you all were seeing my calculator, but you were not. I have to see how I can make that possible. But I guess we're okay for now, as long as you can, read what's on my screen and follow along with the keystrokes. You should be okay. All right. Well, if no questions in general, we'll meet again Monday at the same time. So the way you entered the course through Blackboard, another link up to just enter the course through Blackboard Collaborate. I'm recording the session, so once I figure out how to dig it up and post it, I will. All right, so I guess with that being said, everybody have a good weekend and see you all on Monday.
Okay, thank you.
All right.